We're still talking about rationalizing the denominators of surds, right? And in the last video, we had considered rationalizing a single surd in the denominator. In this video, we'll look at conjugates and rationalizing binomials. That is, instead of having a single surd in the denominator, you have a binomial expression in the denominator. So that's what this video is about. Conjugates and rationalizing binomials. So in two videos before, and I think we already talked about the idea of binomials and everything, but here we want to really look at it deeply. So conjugates and rationalizing binomials. So the learning objectives here, by the end of this lesson, you should be able to define the conjugate of a binomial containing the square roots, multiply conjugate expressions, use the identity for multiplying conjugates, rationalize denominators that contain binomials with radicals, and simplify the resulting expressions. Okay, so the first question we need to answer is what a conjugate is. So a conjugate is formed by changing the sign between two terms. So when we say a binomial expression, it's an expression where you have something plus something or something minus something and all that. So you have two terms, binomial. Bi means two, nomial means terms. So binomial talks about two term expressions. So if we have the expression a plus root b, its conjugate is simply a minus root b. Change plus to minus, and you have conjugate. Similarly, if you have a minus root b, it has a conjugate a plus root b. So the two expressions are identical except for the sign between the terms, right? So um, we can see we have an array of conjugates. So examples of conjugates right here, if I may expand this a bit more. So if you have 3 plus root 5, the conjugate is 3 minus root 5. If you have 7 minus root 2, the conjugate is 7 plus root 2. If you have 4 plus 3 root 6, the conjugate is 4 minus 3 root 6. If you have x plus root y, the conjugate is x minus root y. So conjugates are important because multiplying them removes square roots. So we have conjugates because they help remove square roots when you have binomial terms. So in the previous video, we learned to remove square roots because if you have a single surd, you just multiply by that surd and the square root is removed. But if you have a binomial expression, you actually need the conjugate to remove the square roots. So question, talk about multiplying conjugates. So consider the expression a plus root b into a minus root b. We expand using the distributive law. So step-by-step expansion, you have a plus root b into a minus root b. First, you have a times a, you have a into a multiplied by a, that's a squared. Then you have a times minus root b. So that's a times minus root b, which is minus a root b. And then you have root b times a. Root b times a is a root b. And you have the last terms, root b plus root b times minus root b. That would be minus root b times root b, and that is minus root b squared, which is simply minus b. So if you put it all together, you discover that if you combine all the terms, you have a squared minus a root b into a plus root b minus b, and that is so that's actually like minus root b plus root b. That's zero. That will go, and you have zero there. Then you have a squared minus b. So this whole expression, a plus root b into a minus root b, is a squared minus b. And this is an example of difference of squares, which we have applied in the past. I mean, just to drive home the point again, right? So we are talking about a plus root b, whose conjugate is a minus root b. So you just want to expand this, and we see that a times a. Okay, first we have a into a minus root b. You can have this. Then you can have plus root b into a minus root b again. So we expand it this way. So you then have a times a is a squared. A times root b is minus a root b. Then root b times a is plus a root b again, plus a root b. So you have plus a root b. Then plus times minus is minus. Root b times root b is root b squared, which is b. So you see this cancels this. All right. So this is a squared minus b, like that. So, you can actually write this as a squared minus root b all squared. So in essence, we are saying that a plus root b into a minus root b. Anyone can come first, actually. It's the same thing as a squared minus root b all squared. And that's the whole idea of difference of two squares, which helps us to simplify these kinds of binomial sort with binomial expression, binomial terms in the denominator. So we see this, we now have this important identity that when you multiply conjugates, multiplying conjugates always produces a plus root b into a minus b. It always produces a squared minus b. And this b is technically root b all squared. So this identity is extremely useful when rationalizing the denominators. And that's what we use in this case. So look at this example. You have example 1, 5 plus root 3 into 5 minus root 3. So if you use a squared minus b, so that's 5 squared minus root 3 squared. 5 squared minus 3, so you just have 22 easily. And that just goes like that. So, or if you want to do it in another way, like the way I expressed it, 5 plus root 3 into 5 minus root 3 would just be something like this. 5 plus root 3, 5 plus root 3 into 5 minus root 3. So this is the difference of two squares. So you have 5 squared minus root 3 squared. Okay, 5 squared is 25. Root 3 squared is 3. So 25 minus 3 is 22. So you have that easily like that. So that goes. Then example 2 now. You have for example 2, you have 7 plus root 10 into 7 minus root 10. So that's 7 squared minus root 10 squared. That 7 squared is 49. Root 10 squared is 10. And you have 39 like that. And that goes. Example 3 is also straight to the point. You have 4 plus 3 root 3 into 4 minus 3 root 3. For example 3 now. So you have 4 squared. So first you can square the radical term. So you have, but in short, you have 4 squared. 3 root 2 squared is 4 is 18. So you have 4 squared minus 18. That's 16 minus 18, which is minus 2. And that's the answer. Again, let me do that on the worksheet. 4 plus 3 root 3. 4 minus 3 root 3. Okay. 4. 4 plus 3 root 3. 3, is it 3 root 3 or 3 root 2? Plus 4 minus 3 root 2. I think it's root 2. Yeah. So easily, that's just be 4 squared minus 3 root 2 squared. Okay. So that means you have 4 squared minus 3 squared multiplied by root 2 squared. That means you have 4 squared minus 3 squared is 9. Root 2 squared is 2. So that's 16 minus 18. And that is simply minus 2. And that's our result for that. Minus 2 easily. So you have minus 2 right here. So 13.3 now, we talk about rationalizing binomial denominators. Rationalizing binomial denominators. So to rationalize a denominator, means removing square roots from the denominator of a fraction. So if the denominator contains a binomial with a radical, we multiply by its conjugate. So the general method is that you have 1 over a plus root b. So you multiply the numerator and denominator by the conjugate. So you have a minus root b all over a minus root b. All right, because the conjugate of a plus root b is a minus root b, like that. So multiplying this expression by 1 without so it's like you don't want to tamper with this expression. So you multiply by the conjugate divided by the conjugate. So a minus root b over a minus root b. So multiply by conjugate to remove the square root. Multiply by a minus root b over a minus root b to make sure you have not changed the form of that expression. So you have 1 over a plus root b times a minus root b over a minus root b. And you can tidy that up. So why does this work now? So you see the denominator becomes a plus root b into a minus root b, which now is a squared minus b. So the square root disappears, leaving a rational number in terms of a squared minus b. So example 4 now, you have all this. You have 1 plus 3 root 2. So the conjugate of 3 plus root 2 is 3 minus root 2. So to make sure this expression is not tampered with, you multiply it by 1. And the 1 takes the form 3 minus root 2 all over 3 minus root 2. So you then have 1 into 3 minus root 2. Yeah, that's 3 minus root 2. Down here, you have 3 plus root 2 into 3 minus root 2. So that gives you 3 squared minus 2. And that's 3 squared minus root 2 squared. Root 2 squared is 2 in short because square cancels roots. So you have 3 squared minus 2, which is 9 minus 2, which is 7. Then the whole thing becomes 3 minus root 2 all over 7. Example 5 gives you something similar. Okay, so for example 5 now, okay, let me just go step by step here. So for example, 5, imagine you have 4 over 5 minus root 3. So the conjugate of 5 minus root 3 is 5 plus root 3. So you multiply to make sure you don't change, you don't tamper with this form. You have 4 over 5 minus root 3 times 5 plus root 3 over 5 plus root 3. So you then have 4 into 5 plus root 3 all over 5 minus root 3 into 5 plus root 3. So 4 times 5 plus root 3, you have it there. And that is 4 times 5, 20 plus 4 root 3. Then for the one down, you have 5 minus root 3, 5 plus root 3. So that way 5 squared minus root 3 squared, which is 25 minus 3, which is 22. Overall, you have 20 plus 4 root 3, all right, all over 22. So, and then you can divide, 2 is common here. So you have 2 into 10 plus 2 root 3 all over this. So the 2 cancels 22 here, you have 11. So that's 10 plus 2 root 3 all over 11, like that. And you have example 6 with a similar kind of structure. So for example, 6 now you have 2 over root 5 plus 1. So the conjugate of root 5 plus 1 is root 5 minus 1. So to multiply this expression by 1, you have 2 over root 5 plus 1 times root 5 minus 1 all over root 5 minus 1. So expand that, you have 2 into root 5 minus 1. That's 2 times root 5, that's 2 root 5. 2 times 1 is 2. And then you go for the denominator, that's root 5 plus 1 into root 5 minus 1. So you just do root 5 squared minus 1 squared. Root 5 squared is 5. 1 squared is 1. That's all 4. So you then have 2 root 5 minus 2 all over 4. And then you can factorize this too. So you have 2 into root 5 minus 1 all over 4. So 2 into 1, 2 in 4, 2. So you have root 5 minus 1 all over 2. So the key formula summary we see in this whole thing is that you have the conjugate a plus root b implies a minus root b, and a minus root b implies a plus root b. So a plus root b is the conjugate of a minus root b, and a minus root b is the conjugate of a plus root b. That's the essence of that. So, and then you see that the product of conjugates removes square roots. So you have a squared minus b in that case. And then you can rationalize binomial denominator, where you have 1 over a plus root b times a minus root b over a minus root b. And then the expression becomes a minus root b all over a squared minus b. The essence is that at the end of the day, you don't want to have any square roots in the denominator. Okay, so I'm going to take 2 examples. I'm going to solve 2 of the practice problems as usual, so I can drive the point all the way home. So I take question 10 from 1 to 10 here. Okay, maybe I should see the questions. I mean, everything here is easy, just the difference of 2 squares. Well, I'll do 10 now. 1 over 4 plus root 5. 1 over 4 plus root 5. So for 1 over 4 plus root 5, 1 over 4 plus root 5. So the conjugate is 4 minus root 5, right? So that's equal to 1 over 4 plus root 5 times 4 minus root 5 all over 4 minus root 5. So 4 minus 5 over 4 minus root 5 is as good as multiplying by 1, right? Because this divided by this is 1, right? So, and if you multiply something by 1, nothing, the structure remains. So you have 1 times 4 root 5. So you have 1 into 4 minus root 5 all over 4 plus root 5 into 4 minus root 5, like this. So, and that means you have 1 times 4 is 4, 1 times root 5 is root 5, all over, for this now, difference of 2 squared. So you have 4 squared minus root 5 squared. So that means you have 4 minus root 5 all over, so 4 minus root 5 all over 4 squared is 16, root 5 squared is 5. Okay, so that's 4 minus root 5 all over 16 minus 5 is 11. So you can leave it this way, and that is your answer. Or you can go further and say this is 4 over 11 minus 1 over 11 root 5. Anyhow you like it, this is also okay. So, but you can always check with your calculator to see if what you have done is right. So you have 1 over 4 plus root 5. Okay, let's check that on decimals. 1 over 4 plus root 5. Okay, so you have 1 over 4 plus root 5. So 1 divided by 4 plus square roots of 5. See that what that gives you. And when we solved it, when we rationalized, we ended up getting 4 minus root 5 over 11. Okay, 4 minus root 5. So we got 4 minus square roots of 5 all divided by 11 all over 11. Okay, so you see the result is exactly the same thing. So that's to show they are exactly the same. So that's first one. Second one now, we have from 11 to 20. So we have this 11 to 15, for instance. And then we have this now. Okay, I mean, it's looking pretty like pretty much like what we did before. So let me look for one that can be a bit challenging. Yeah, it doesn't look so quite so challenging, but anyway. So in that case, I'm just gonna pick let me pick something negative. Okay, yeah. Maybe I'll go for 20 again. 8 over root 3 minus 2, right? 8 over root 3 minus 2. 8 over root 3 minus 2. So for 8 over root 3 minus 2 now, so 8 all over root 3 minus 2. Again, we have the conjugate to be root 3 plus 2. So that will be 8 over root 3 minus 2 times root 3 plus 2 all over root 3 plus 2. So that means we have 8 into root 3 plus 2 all over root 3 minus 2 into root 3 plus 2. So we then have uh, 8 root 3. 8 times 2 is 16 all over difference of two squares now. So we have root 3 squared minus 2 squared. So that is 8 root 3 plus 16. Root 3 squared is 3. Root 2 squared is 4. So we have 8 root 3 plus 16 all over minus 1. So that means we have minus 8 root 3 minus 16. Okay? Is that what works? No, no, no. That'll be that'll be minus 8 root 3 plus 16. Or I mean, if you like, that's just like minus 8 root 3 minus 8 root 3 minus 16, or minus 16 minus 8 root 3, whatever. So we go back. So 8 over root 3 minus 2, right? 8 over root 3 minus 2. So we check that using our calculator. 8 over root 3 minus 2. 8. 8 over root 3 minus 2. That's 8 all over root 3 minus 2. So we have that. And then the result we got now is minus 8 root 3 minus 16. Minus 8 root 3 minus 16. So that's minus 8 square roots of 3 minus 16. So you see exactly the same, minus 29.85 minus 29.85. So with that, we come to the end of this interesting video about rationalizing, conjugate and rationalization of sorts like that, rationalizing binomials. So when you have binomial expressions, you get the conjugate and you multiply, you rationalize it in conjugate. So don't forget to try your hands on the practice questions. So you have this one of 5, 6 to 10. All right, 6 to 10. You can see this 11 to say 15, 11 to 15, and then 16 to 20. So try your hands on them to be sure you really get the gist. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed to this channel already, I thank you very much for doing that. If you haven't subscribed, go ahead and subscribe. You have a lot to learn. I have tons of videos on different aspects of mathematics, data analysis, data science, and all of that, Python programming. And you really want to avail yourself of this opportunity. All right. So subscribe, hit the notification bell so you can always get alerted each time a new video is released. You can then become a member of this channel if you like. That gives you some special privileges like getting to see some videos first and being the only one to see certain videos that only members get to see. You can also request for PDF copies of my notes. I have PDF copies for some of the topics I teach, so I can give you the copies for your learning, and then we can also hang out together to discuss whatever interests you on this channel, either physically, if you're ever in the same geographical location, or online like this. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.